Okay, so if the leading exponent is even, x squared, x to the fourth, x to the sixth, what do those graphs do at the left and right ends? What do graphs like x squared, x to the fourth, and x to the sixth do at the left and right ends?
They go infinity circle and
They go positive infinity on both sides, right? What happens if we put a negative sign in front of that leading term with an even coefficient, even exponent? What happens if we put a negative sign in front of it? What does it do? It flips the sign. So what does the graph look like now?
Inverse.
Goes down on both sides now.
That's all, right?
That's how we see this. It's going down on both sides because we have an even power in front, but a negative sign, so it goes down on both sides.
Yeah, I know.
All right, 3. X cubed minus 2. So 1 was C, and 2 is E. What's x cubed minus 2? Let's look at what was number 3. Well, who did number 3? I believe you were in charge of number 5.
I did I got it right already.
It's D.
You give me.
It's D, yes. Why is it D?
D because it's going down by 2.
So what's going down by 2?
The Y.
I'll need the code.
Which graph that you know is going down by 2? You're right to obtain this by shifting the graph that you know. But which graph is it?
D.
It's not the last.
That?
I know. What graph that you know does this look like?
X cubed.
Exactly. So you shift x cubed down by 2.
Change it, go back to Gucci.
Okay, let's go to 4.
Go on.
You guys were back there working on 4, right?
Yeah.
I told you to start out by factoring an x out. What do you get when you factor an x out?
It wasn't x and x squared minus 8x plus 15.
Okay.
Okay. During class, right? That'll be the last time. And then it's gonna be x squared to factor.
Okay, what can you further factor?
Yes.
What does the inside factor as?
X.
What two number looks like would be 15?
Negative 3x.
Negative, okay, I heard negative 3. What else? What equals 1 negative? You gotta get 15.
Negative 5.
Negative 5. So what are the roots of the x-intercepts in this parabola? What are they?
The roots.
What makes this parabola 0? What makes this factor 0? 3 and 5. 3 and 5. What else? There's another way of making this 0 as well.
The X.
What can I can just set x equals 0 and that would also make it 0, right?
Yeah.
So the roots here, if I make this first factor 0,
So 4 is A. Yeah.
4 is A. Well, does that cause the x-axis at 0, 3, and 5?
Yeah.
Yeah, yes.
It starts at 0, 3, and 5.
Uh-huh. What about the behavior at the left and right ends? Does the behavior at the left and right ends make sense given that its leading term is x
Yeah,
cubed?
because it's
What is it doing at the left end?
going down.
Negative infinity. Is that what the leading term x cubed does?
Yes.
What about at the right end? What should it do at the right end?
Positive. It's going to be like.
Does that make sense? Is that what x cubed does? Does x cubed go to positive? Yeah. So the behavior at the left and right ends is consistent with like with an x cubed type graph. So yes, 4 is indeed A. Okay.
We're talking about.
Last one is 5. Last one is 5. Okay.
We did it already, bro.
Okay, tell me how we did it.
We factored We factored B.
We factored x squared minus 16 is what?
X minus 4 times x plus 4.
Okay.
That's the easiest way.
So what then are the roots of this? What are the x-intercepts?
4.
Negative 4, positive 4.
4 makes this factor 0, right?
Yes.
Yes, sir.
What makes this factor 0?
Negative 4.
So what makes the answer? Ah! we're going to let t equal x squared. Everywhere you see x squared, replace it by t. Can you factor that?
Yeah.
How would you factor that?
Yeah.
Find two numbers and multiply to give you 36, right? And add up to negative 13. Can you think of two numbers and multiply to give you 36? Those are the first ones that come to my mind. Do those add up to 13? Negative 13? 9 and 4 add up to 13. Negative 9 and negative 4 add up to negative 13.
Smash that 9 and has that big.
Okay. But we don't want our answer in terms of t, we want it in terms of x squared, so we're going to substitute back in.
I'm gonna go to sleep.
Okay. So, can we further factor this?
X to the fourth, I guess. No, yeah. We can find
X squared minus 9 and x squared minus 4. You know a factoring technique for those. You know, guys haven't studied the difference of squares technique? No? Well, I need two numbers that multiply to give me negative 9 and add it to 0. I can think of two numbers that do that. Exactly. 3 and negative 3 give me negative 9 and they add up to 0. Right? Because my x term is 0 here. Similar thing with x squared minus 4. If I take 2 and negative 2, those multiply to give me negative 4, right?
Yeah.
2 times negative 2 plus negative 2 is 0. 0 is my x, is the coefficient for my x term because there is none, right? If there's no x term, that means the coefficient in front of the x term is 0. So what are the roots of this? Exactly. Okay. So, how is this polynomial going to behave at the left and right ends? Has an x to the fourth term. The leading term is x to the fourth. How is it going to behave at the left and right ends? What does x to the fourth do as you go to negative infinity and as you go to positive infinity?
It's going to go to positive infinity.
Exactly. He's exactly right. Yeah, it's in the middle, right? It's going to be squiggly. I don't know how you
It's going to go up.
Exactly. And just at the left and right end, it's going to go up on both sides because it looks like a parabola, right? It's like a steep parabola. So it's going to cross the x-axis at -3, -2, 2, and 3. It's going to go up at both ends. It's going to come down and hit -3.
Yeah.
What's it's going to do? It's coming down, right? So it's going to go down, keep going down first, and then it's going to come back exactly. Go up. Maybe down to 2, and it's going to keep going down, right? It's going to do what? Does it keep going up after 3?
Yeah.
Because it goes up exactly. Okay. All right. So I only want to do one more thing. Yeah, question?
Wow.
This is the best phone about ever.
I said this was going to be about double roots. I want to do one more thing before I just turn you back to working for the last few minutes. The last thing I want to do is I want to consider what would happen if we multiplied this whole expression by x squared. The factored form would end up being the same, except now it would have an x squared in front. Now that was factored as x squared times x minus 3 times x plus 3 times x minus 2 times x plus 2. How would the roots change if I had this x squared term out in front? There would be an added root, right? X equals 0 is added as a root. As a matter of fact, I'm going to rewrite it like this. We're going to x times x.
We in Saturday right now. You
You can think of x equals 0 as being added as a root, not once, twice. What is x times x?
If you put right, see,
I'm going to say this is a double root.
here's the difference.
So how would the graph change now? This part is still the same.
Now, I like my girls like this.
Now, but now it has to go through the origin, doesn't it? If 0 is not root, it has to go through the
I
origin.
could drop my phone like this.
So it was going up at -2, so it must go up and then come down, right? Okay.
It goes up and then.
What happens after 0? Does it keep going down?
It go up.
What shows you?
It has to go up.
What should
Yeah.
Does it go down and then come back up, or does it go back up and then come down?
Should it go down?
Should it keep going down? That's the question, right? Well, it's going down now, right? Why should it keep going down? But he's right. The only way to know for sure is to plug in 1. If you plug in 1 here, you're going to get 1 times 1 is 1 squared. 1 minus 3 is -2. 1 plus 3 is 4. You can plug in 1 to see whether it's positive or negative. If you work all this out, you're going to get -2 times 4 times -1 times 3. You're going to find that it's going to be positive. It's going to be positive in between 0 and 2. So this is interesting. It doesn't keep going down.
You follow?
It goes up. Why does it not keep going down? Why does it just bounce off the x-axis at 0? Why doesn't it keep going down? It suddenly changes directions. Not only does it cross the x-axis, it doesn't cross the x-axis at 0. It just touches it and then suddenly changes direction. Why is that? We say that a root is where it crosses the x-axis, but it doesn't actually cross the x-axis here, does it? It just touches it and then changes direction. Why is that? Think about y equals x squared. You know the graph of that? Where is its x-intercept? Where's the only place the graph of y equals x squared touches the x-axis? Does it cross the x-axis though, or does it just touch it? So this looks exactly like x squared near the origin. It looks just like the graph of y equals x squared near the origin. Anytime you have a double root, it looks like the graph of y equals x squared. It just bounces off that x-axis. What if there were a double root right here? What would it do at 3 in that case? What would happen at 3 if there was a double? It should touch it and then suddenly
go up.
Yeah, so it should just bounce off 3 if there was a double root. What do you think happened? We say that's a root of multiplicity too. What do you think would happen at a triple root? What would it look like if you had a triple root?
You was crazy though. She cut the hair too. So she was going to be like that.
What do you know that has a triple root? Can you think of a polynomial function that you know that has a triple root? Like a cubic term. X cubed is the simplest one, right? So if it had a triple root at x minus 3, it would look like that. It would suddenly flatten, it would briefly flatten out. Okay?